So to calculate the mean APGAR score, what we needed to do was we needed to take each possible value for the APGAR score, multiply it times its probability, and then add each of those together. So the first possible outcome is a score of 0. And if we multiply it times its probability, we would be multiplying that times 0.001. Then we're going to take our next outcome, 1, and multiply it times its probability, 0.006. Then our next outcome, 2, times its probability, 0.007. Then our next outcome, 3, times its probability, 0.008. And so on until we get to our 10th outcome times its probability, 0.053. So when you did that, you should have got 0 plus 0.006 plus 0.014 plus 0.024, and so on. So when you added all of those values up for your mean, what you should have got was 8.128. So yesterday we said that the median, the 50% mark, fell somewhere in the 8 range. And we're seeing that our measure of center using the mean is actually pretty close. So the mean value, the mean APGAR score, of a randomly selected newborn is 8.128. So now that we know the mean APGAR score, we can use that to calculate the standard deviation. We're going to start by finding the variance, and then once we have the variance, all we have to do is take the square root of that variance to get the standard deviation. So we said that to find the variance of x, we have to multiply the squared deviation of each outcome times the probability of that outcome. So our deviation for a score of 0 would be 0 minus the mean, 8.128 squared, times its probability, 0.001. Then our next squared deviation would be 1 minus the mean, 8.128 squared, times the probability of having a score of 1 is 0.006. Then we would take our next deviation, 2, minus the mean, 8.128, square that, and multiply it times the probability of a score of 2. And so on. And we could use our calculator. If we take our first squared deviation and multiply it times its probability, we get 0.06606. Our next squared deviation times its probability would be 0.30485. Our next squared deviation times its probability would be 0.26287. And we would continue that process until we got to our last possibility, which would be 10, and find its squared deviation, multiply it times its probability, 0.053. And if we continued that process using our calculator, we would get that our variance, which again is sigma squared of x, would be 2.006 0, 6, 5, 6, 1, 6. And once we have that variance, we could calculate the standard deviation simply by taking the square root of that variance. So our standard deviation is going to be the square root of 2.065616, which gives us a value of 1.437. So they wanted us to compute the standard deviation. We have that, 1.437. They also want us to interpret that standard deviation in context to the problem. So remember, the standard deviation is how far our observations fall from the mean on average. So what we're saying here is that a randomly selected baby or newborn is going to have an APGAR score that typically differs from the mean in either direction by this much. So a randomly selected newborn's APGAR score will typically differ from the mean, which we said was a score of 8.128, by about 1.437. In other words, a score that's 1.437 points above or below the mean, 8.128, we would consider within the typical range for APGAR scores. Now, I didn't write out every step here, but I calculated this number by typing all of that into my calculator. So I would have kept going with that process. I would have taken the deviation for 3, squared it, and multiplied it times the probability of 3. The deviation for 4 and squared it and multiplied it times the probability of 4. And I would have had to have done that for each outcome until I got to the 10th outcome. So basically I have 11 different squared deviations times the probability and then adding them all together. So you can see where this process could start to get a little bit tedious. What I'd like to do is I'd like to show you how you can calculate the mean and the standard deviation for a discrete random variable using your calculator. And in order to do this, we have to take our probability distribution and we're going to enter it into two different lists. Our first list needs to contain each possible outcome, and our second list needs to contain the corresponding probabilities for each of those outcomes. So I'm going to put each value in list 1, and I'm going to put the probability of each of those values corresponding to them in list 2. So my values, let's see if I can position this so that there's not a glare, but it's still visible. My values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. In list 2, I'm going to put the probability of each of those outcomes. So the probability of 0 is 0.001. Probability of 1 is 0.006. Probability of 2, 0.007. Then we have 0.008, 0.012, 0.020, 0.038, 0.099, 0.319, 0.437, and 0.053. So again, our values are in one list, and the probability of each of those outcomes is in list 2. Once you have all of that entered into your list, you can exit, so second mode to quit. And we're calculating mean and standard deviation. So if you remember from before, when we're calculating the mean and standard deviation of a set of data, we go to Stat, we go to Calculate, and we ran one variable statistics, option 1. We're going to do the same thing here. What we want to do is we're finding the average of the values. So our list is going to be the list that contains all of our outcomes, the 0 through 10, and that was list 1. But this time, we've been leaving the frequency list blank. Now we're going to input a frequency list. The frequency list is saying, what is the probability of each of these outcomes? And the probability of each of these outcomes we put in list 2. So for frequency list, we're going to put in list 2. This is going to give us a weighted average. It's going to multiply each of those outcomes times the probability of the outcomes that's entered in our frequency list. So now if we go to calculate, notice that we get X bar, our mean, is exactly what we calculated before, 8.128. Notice that the sample standard deviation is no longer there because we're not talking about a sample. We're actually looking at the probability of each and every outcome. So it's not a sample, but we do have the standard deviation sigma of X. And notice that we got 1.437, which was exactly what we got when we calculated it using the formula. So again, we can calculate the mean and standard deviation of a discrete random variable using the formula, but we can also do it by putting in the probabilities, our weighted values, into the frequency list and running one variable statistics just like we did before. And then it'll go ahead and weigh each of those outcomes for us, which saves us a little bit of time.